Guys, welcome to the show. Today I have with me the 128GB version of the MacBook Pro M4 Max, also the 64GB version. And I figured I'd just do a comparison on why you might need 128GB. Do you know why? Can you tell me why? Write in the comments right now why you need 128GB. Future proofing, but next year's one's gonna be faster. So, you know, do you need to proof the future? Do you need to proof it? Or do you want an excuse to buy next year's one? So maybe 64 will be good out of the box for that. But anyway, I'll tell you the answers and I'll show you some demonstrations after I tell you what happened. So if you want to run Llama, the 405 billion parameter version, it's not going to work on a 64GB version. However, you can get it running on 128. It looks like you. There you go. And 5 years later, we'll get a response. Runs very slowly. Very slowly, but it is possible. You just have to use the quantized version, the compressed version, and it runs. And that is pretty impressive if you want to do some sort of private AI on your local system and you don't want to reach out to the chat gyps, privacy people in the world, stealing all your data.
Allegedly.
I know what you're doing.
Legal disclaimer, no I don't.
If you want to convert text into video, it does run on the 64GB version, the standard situations. However, it doesn't run out of the box on a 128. Why? Because most people do not have 128GB. So there is currently a bug in which it asserts, which means it crashes in the metal shaders. That bug's been around for the past 2 years, and it's on people with 128GB systems. Hasn't been fixed because there isn't enough people complaining about it. So maybe if you get 128 and complain about it, you might be able to fix it. So metal performance shaders, and it's got the array situation. It's probably an easy fix if someone gets around to fixing it. It's just an assert. There is a workaround. I did work around it. And I ran them both on these two systems, and the 128 actually ran twice, more than twice. It finished the job in 10 minutes, whereas the 64GB, it did do it, but it did it in 21 minutes. And that's because it had to constantly thrash the model in and out of the memory, between SSD back into the memory, and that really was a big bottleneck for it. So that's what really slowed it down. Compared to my PC with only 16GB RAM and a 10GB graphics card, the RTX 3080, that one ran it faster. It was about 50% faster running it than my M4 Max. But that being said, this code isn't really that optimized for Max at the situation. It was running on a GPU, but via the CPU rendering pipeline. So there is improvements to be made. So the fact that you actually got it up and running is impressive. And the fact that it ran Llama 3.1 405B is impressive to me, even though it's very slowly. Other things you might want to do, if you want to do some training, that requires about 50GB of RAM for some models. If you want to just add some more images for the database for it to figure out, if you want to ask it about different stuff. They both work on both systems. And like I said, it's going to be slightly faster if you are memory constrained on your system. Other situations like Unreal Engine or Blender, render, tests, performance, all that kind of stuff, no difference whatsoever, because those applications aren't memory constrained. What you want to do is you want to go into Activity Monitor and you want to see your memory usage over here and that green bar. If you see it in the reds, that's when you might get performance, well, you probably will get performance improvements by going for a better spec system. Whereas if it's mostly in the green, which most of the time is, you're probably not going to get any improvements. And if you're the kind of guy that maybe has a lot of multitasking applications running at the same time, like if you've got virtual machines running, hogging that piece of memory, you got Chrome hogging that piece of memory, Final Cut hogging, basically, if you don't want to close your applications, then maybe having a 128GB system might be kind of useful. But for now, let's jump into the test and show you the kind of impact you get and the difference it makes. Got a suite of different applications to show you if there's going to be a difference in your use case, virtual machines, all that kind of stuff. But I'm going to start the show with machine learning, Apple intelligence of kind of like stuff like that. So I've got this one here is a text to video generator. It's going to use models in the machine Merlin's world to get a bit of text and turn it into a piece of video. And look what happens when I try to run the conversion. I'm going to go ahead, start on 64. 64s go ahead and starting to run. And on 128, it's running as well. And if you look at the terminal right here, they're both proceeding along. I'm not going to get Activity Monitor yet because something's going to happen on 128. When it starts to load that last model, boom, right there, Python has quit unexpectedly, yet the 64GB version is running successfully. So there's some issues in the 128GB version. Same piece of code, just the hardware slightly different. And it says right here that it's crashing in the metal performance shaders because the array has a 2**32 issue. And if you type that code into Google, you find that this bug has been around for 2 years now, since 2022. Hasn't been fixed in 2 years. There is a workaround, so we're actually gonna get some performance metrics going. There is a workaround to get it going, but yeah, it hasn't been fixed in 2 years. So if you are getting 128 gigabytes, one of the issues you might run into is some of the applications might have bugs for reasons, and the bugs might not be fixed because most people out there don't have 128, so they're not gonna fix it. You have to be the person, the pioneer out there to fix it. Knock on Apple's door. Apple, please fix it. Yeah, so let's get this running over here. I'm gonna just stop there. So memory-wise, you can see on the left here on 128 gigabyte version, it's already using 96 gigabytes of memory on this application. And on the 64 gigabyte version, it's using 59 gigabytes. So the 64 gigabyte RAM version is on step number 2 out of 20, with rendering out 20 frames, whereas the 128 gigabyte version is already on step number 3. And the iterations per second here, it's now dropped to 31 seconds per iteration. So 30, whereas on the 128 gigabyte version, it's 22 seconds. So that's about a 50% slowdown. And if you keep it running, what you're gonna find is this test is gonna finish, and it's gonna take the 64 gigabyte RAM version 21 minutes to finish, and the 128 gigabyte RAM version is only gonna take 10. And that is, activity monitor is our friend here. I'll just make it slightly bigger. On the 64 gigabyte RAM version, because there isn't enough memory to fit all of the required data in the memory, it's having to thrash out the memory between the actual RAM and the SSD. So that thrashing that has to go around loading out data is causing the GPU to not work at 100%. So you can see on the left here, 128, it's just rocking the GPU just non-stop, boom, 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 boom. Whereas on the 64 gigabyte RAM, because of all that thrashing from the memory, it's not going at its 100% speed, and that causes that bottleneck, and that causes the slowdown. But on the positive, what you find is the 64 gigabyte RAM version actually works. It's slower for this intense use case. It's slower, yeah, half the speed, but you know, if you want to test it out, it still works. And something you can do is you don't need, if you're working on these systems, unless maybe you're Mac for life and you don't want to go anywhere else, you don't need to render everything at full resolution. So for example, if I reduce the resolution of the output image, if I make it 512 by 256, so on the right here, on 64 gigabytes one, it takes 3.5 seconds per iteration. On the left here, it's also 3.5 seconds per iteration. So when you reduce the actual required RAM, it is the same speed. So it's only if you're at a bottleneck. Now, these situations may compound if you're doing multitasking. So for example, if you've got a virtual machine running in the background that hogs memory, if you want to run a bit of Chrome, that's going to take another 10 gigabytes of memory. All these browsers, all these running lots of applications at the same time, you're going to get a bit of meat with the 128. But the only question you need to ask yourself, is this M4 system the system to actually go for? Because for example, if I just log into my PC, my Windows PC with an NVIDIA graphics card, you can see an activity monitor here. We've only got a 10 gigabyte graphics card, NVIDIA. It's 2 years old, 3080. And we've only got 16 gigabytes of memory. Yet this computer, not this one right here, the one that I'm remoting into, can actually perform this conversion about twice as fast as the M4 Max. So maybe spending the extra grumph on the memory for, you know, machine learning kind of stuff, maybe better off just getting a Windows NVIDIA solution for this stuff. But if you are Mac for life, then I understand. And there's a lot of headroom to get a lot of performance out of these systems. For example, while this is being run on the GPU on the PC, on the actual M, it's running on a GPU, but via a CPU rendering solution. It is approved by Apple. Apple was the one that actually have released it and got it going, but there is a lot of headroom to get the algorithms running faster, potentially. And the great thing about Mac is that it uses unified memory. So whereas on the PC, you'd be limited on getting 24 gigabytes of an NVIDIA card, unless you're kind of like Elon Musk level richness, and you can afford the proper, the Q, you gotta wait like 2 years for a H100. Anyway, if you're a consumer, prosumer, you're probably limited to 24 gigabytes on the graphics card. So maybe for some cases, bit of programmers out there, maybe you guys out there could make things run a lot faster out there in the world. So potentially there is a lot of movement to get the stuff working better on Mac. And if you do, please let me know, because I'd love to test out your systems and work with you guys. That'd be amazing. But I'm hoping that you guys are getting a sense of how much the performance can improve between the 64 and the 128 when you switch it up. So I'm gonna go back into activity monitor up here. We can see everything's finished, and it took 95 seconds on the test on both systems. And that's because we reduced the resolution of the video that we made at the end. And if we just look at the output result, you can see that they're all exactly the same. So the results are exactly the same right there. So the difference you're gonna be making here is if you pump up the resolution to, let's say 1024. So what we got right now is when we're trying to run this maximum texture version, just minimally maximum, slightly maximum, we're using 59 gigabytes of RAM, but also using 39 gigabytes of the swap. So it's allocated a piece of the SSD and it's just constantly writing in and out for that memory, and it's 38 gigabytes. And if we leave that running for a bit, it's actually gonna come with an error. And it has actually come with the error because it's used up 45 gigabytes of the swap, and it says max allowed memory is 81. It tried to allocate a gigabyte and it says it's out of memory. It does also say that you can disable that error, but it might crash your system. Now these are new systems, I don't want to crash them, but you're going to be running into a lot of swapping issues. And something else to consider is if you are requiring a lot of data to be used, is it a good idea to be constantly writing to your SSD? SSDs don't have the best endurance out there in the world. So if you're constantly writing gigabytes in and out, in and out, in and out, it might degrade your SSD quicker than a normal person. So make sure you get Apple Care if you are going to be trying to run some large models on the 64 gigabytes, or just maybe that's worth it for the, maybe it's worth then considering the 128 if you want to use your computers a bit longer. So I've rabbited on about this example for a while. I want to switch it up to see if something that I wish would work on 128, I would actually get the 128 for it. And that is, can I get Llama 3.1 405 billion parameter version running? So let's try Llama 3.1 over here, 405 billion parameters. They're both thinking about it. Let's get the activity monitor up. And we can see the memory is climbing. We're already on red on the 64 gigabyte version, and that is going to crash very soon. And on the 128, we are using 128 right now. And we started using swap, 20 gigabytes, 25 gigabytes, 31 gigabytes. It's already crashed on the 64. It's got a little bit more of a dance going on the 128. But yeah, it's crashed right there, boom. Hello. So this is EXO running right here. Let's try get it to load the 405 billion parameter model. Testing. We got everything downloaded, so it should be good. So jumping on the node here, nothing is downloading and all three computers are connected, as you can see over here. And if we go into activity monitor, we are flooding the memory with 116 gigabytes. And unfortunately at this stage, it's just gonna crash. It's actually crashed on both 64 machines. It's kind of overloaded it. The 128 still works, but 64 over here and the M1 Max 64 is completely crash-ate. And what's really cool is it crashed so bad on the 64 gigabyte system that the actual whole system is not responsive. It's just saying that the watchdog didn't report back in 94 seconds, so it just crashed after a minute and a half. So right now we're running the quantized version of the 405B. And as you can see, the memory we're using 125 gigabytes. Swap uses 23 gigabytes. It's taking its sweet time to figure out the answer, but fingers crossed we're gonna get an answer. Meanwhile, on the 64 gigabyte version, boom, terminated. Just not enough RAM to run it. So let's see what answer we get on the slower version, but hopefully should fit into that 128 gigs. It says it looks, and we've got the GPU going. This model is running very, very slow, eerily slow. But if we just leave it alone, the fact that it's able to run the 405 billion parameter model, that is really cool. But the results looks like we got another character there. It looks like, so it is able to run it very, very slowly. So that's one thing you can do on a 128 gigabyte version that you can't do on 64. Is that worth it? Maybe it's good. Try some stuff out. It's pretty cool. I really like the idea of running the large models, and maybe over the next year, there'll be some other large models coming out. But probably if you want to get into this space, you need more than 128 gigabytes. You probably want to get maybe the next Ultra, the one that those come out. But the fact that it can run on a laptop, That is amazing. That's really, really amazing. That's what's really good about Max, the unified memory model. It looks like you. There you go. And 5 years later, we'll get a response. All right, so what did you guys think of that demonstration? I think most of the time you're not going to notice any difference whatsoever. It's only if you're doing super advanced stuff, that's when you might notice a difference. And something I'd say is when I got my MacBook Pro, the M1 Max, I've had that for 3 years. I didn't need 64 gigabytes. However, I got 64 gigabytes and it's been very beneficial for me to have that 64 gigabytes because over the last 3 years, I've actually got to use a lot more. I've been doing a bit more than punching above my weight in that situation, and having 64 gigabytes meant that I didn't actually need to upgrade my computer when I had ran into an issue. So if you're the kind of person that doesn't want to upgrade every single year, want to upgrade every few years, then having more RAM than you need right now, today, is useful, especially because these machines aren't user serviceable. But on the flip side of things, probably if you don't need 128 gigabytes now, you're better off just getting what you need, because next year the CPU and GPU is going to be faster. And even though you couldn't get some of these big models running on these machines, they run very, very slowly. So it might be beneficial to have a faster system for running these super heavy models. It's probably not worth playing around with them. And you're probably just better off waiting for, you know, the M4 Ultra, Mac Mini Ultra. That's going to be something to play around with. That's going to be really, really fun to try out with. But let me know, what use cases are you guys thinking of for using your 128 gigabyte RAM versions? Or do you just like spending money, supporting the Apple cause, getting some business tax breaks? Is that what you're after? Let me know in the comment section below. Hope you guys found this video useful and enjoyed the show.